far beyond the orbit of Neptune, past the frozen remains of comets and dwarf planets, past the very edge of the sun's protective breath, something still drifts. It is small, fragile, unremarkable by today's standards, a box of circuits, wires, and instruments powered by the slow decay of plutonium. And yet, it is the farthest thing we have ever made. It is Voyager 1. Voyager's journey began in 1977, in an era when the internet did not exist, when computers filled entire rooms, when the thought of leaving the solar system belonged more to science fiction than to science fact. NASA's engineers built it not to last forever, but long enough to take advantage of a rare planetary alignment, one that occurs only once every 176 years. With this alignment, Voyager could slingshot from Jupiter to Saturn, stealing momentum from their immense gravity wells and racing outward faster than anything built before. The mission was ambitious but finite, a 4-year tour of the outer planets. Few believed Voyager would still be alive decades later, sending faint signals from interstellar space. Fewer still imagined it would become a vessel for mysteries that even now defy human understanding. In its first years, Voyager 1 transformed our view of the solar system. It revealed Jupiter not just as a giant ball of storms, but as a system alive with moons, Io with its volcanoes, Europa with its hidden ocean beneath ice, Ganymede with its magnetic field. Saturn gave us Titan, shrouded in thick atmosphere, and rings more delicate and complex than any earthbound telescope could resolve. These were not dead worlds. They were dynamic, alien, alive. By 1990, Voyager had completed its planetary mission, but before shutting off its cameras forever, it turned around for one final glance, a mosaic of the solar system, where Earth appeared as a pale blue dot suspended in the vast darkness. That single pixel, Carl Sagan reminded us, contained everyone who had ever lived, every empire ever built, every joy and sorrow in human history. Voyager had given us not just science, but perspective. Then it continued outward, past Pluto, into the frozen void of the Kuiper Belt, and farther still. Decade after decade, as generations on Earth passed, the probe kept going. Powered by its dwindling radioisotope generator, it continued to hum, faint but steady, its signals taking over 20 hours to reach Earth. And then, in 2012, it crossed the heliopause, the boundary where the solar wind yields to the pressure of the galaxy beyond. For the first time, something built by human hands had entered interstellar space. Scientists expected silence. They expected emptiness. But what Voyager found was far stranger. Its instruments detected plasma waves ringing through the void like the strings of some unseen instrument. It measured magnetic fields not fading, but intensifying, twisting unpredictably. It revealed that interstellar space was not still. It was turbulent, dense, and alive with unseen forces. The region beyond the sun's influence was not a vacuum, but an ocean, and Voyager was its first sailor. For years, this was its gift to us, data that reshaped our models of the galaxy. But then, in 2024, the tone of Voyager's transmissions began to change. At first, the anomalies were subtle. A burst of magnetism stronger than any seen before. Unexpected spikes in plasma density. Fluctuations in readings that did not match predictions. Engineers assumed aging instruments were failing. After all, the probe was nearly 50 years old. But the anomalies persisted. And then, the impossible occurred. One of Voyager's external arrays, not designed to detect thermal radiation, began reporting sudden rises in temperature. Heat in interstellar space. It should not have been possible. Yet the readings came in pulses, repeating rhythms, too precise to be charts. Something out there was not random. It was structured. Soon after, the probe's trajectory shifted. Not by much, but enough to be measured. Voyager was no longer moving along its expected inertial path. Something invisible, was nudging it. Its antenna, though blind to visible light, realigned toward a fixed coordinate in space. A point with no stars, no galaxies, nothing known. Like a compass aligning to a magnetic field, Voyager had found something. Then, Dormant subsystems flickered back to life. Instruments long shut down to conserve power began transmitting again. But the data they sent was unfamiliar, compressed in formats Voyager had never been programmed to use. At first, the team thought the files were corrupted, damaged by cosmic rays. But when decoded, patterns emerged. Recursive structures. Logic. Almost like encryption. Applied AI analysis suggested the data carried symbolic information. Not random, not noise, but meaning. And when cross-checked against the low-frequency pulses Voyager had recorded weeks earlier, the structures matched. Whatever had imprinted itself upon Voyager was now speaking through it. This led to a chilling possibility. Perhaps Voyager had passed through more than the heliopause. Perhaps it had crossed into something else. The heliosphere, long thought to be a protective bubble, is not static. It breathes, expands, contracts, fractures. Voyager revealed these fractures, rifts where interstellar matter seeps in, zones where energy behaves differently. What if one of those rifts is more than just a crack in the sun's shield? What if it is a threshold, where space-time itself thins, where the rules of physics change? If that is true, then Voyager's anomalies are not malfunctions. They are the fingerprints of another domain. In early 2025, the probe delivered its strangest transmission yet. Buried deep within its data stream was an ultra-low frequency pulse, repeating with exact precision. When analyzed, the pulse revealed harmonic overtones consistent with known natural resonances, except magnified, shifted, and repeated in impossible intervals. Some dismissed it as interference. Others called it what it resembled most, a signal,